Good morning everyone. Today in this session I am going to discuss regarding the classification of elements and periodicity in properties. In the early 18th century, only 31 elements were found. In 1865, 63 elements were discovered. It was very difficult to remember the properties of 63 elements. Hence, there was a need for classification of elements. The elements having the same properties were grouped together. In this way, the classifications of elements has been made. The classification of elements, many scientists contributed. In that first one is Doberaner. Doberaner law of triads. The three elements having the same physical and chemical properties are arranged in increasing order of their atomic weight. For example, the first triad is the lithium, sodium and potassium. Lithium atomic weight is 7, sodium is 23, potassium is 39. The atomic weight is increases from lithium to potassium. This is one triad. It is triad 1. Three sets of elements having the same chemical and physical properties and arranged in increasing order of their atomic weight. If you see the atomic weight of the center atom, atomic weight of center atom, atomic weight of sodium is nothing but the mean of the first and the third element. Atomic weight of the middle element is the mean of the first and third element. If I take the atomic weight of these two and if I take mean, it is 23. 23 is the atomic weight of the sodium. Similarly, he gave another triad. Triad 2. Chlorine, bromine, iodine. Chlorine 35.5, bromine 80, iodine was 127. Atomic weight of bromine. Atomic weight of bromine is the sum, the mean of the first one 35.5 plus 127 divided by 2. You get approximately around 81.25. This is not exactly but it is nearly equal to that of the atomic weight of the bromine. He gave another triad, triad 3. Triad 3 was calcium, strontium, barium. Calcium was 40, strontium 88 and barium is 137. Atomic weight of strontium is the mean of calcium and barium. Atomic weight of strontium is 40 plus 137 divided by 2. You get 88.5 is the atomic weight for the strontium, but it is 88. Approximately it is same. Doberaner gave the three triads. He was unable to give the triads for the other elements which were discovered at that time. This was its drawback. But its merit is he was the first scientist who grouped the elements, made the group elements. He gave a relationship between the atomic weight as well as chemical and physical properties. The credit of grouping of elements and relating the atomic weight with that of the chemical properties goes to the scientist Doberaner. After Doberaner, the next the musical notes. You know that musical note in nature is having only 7, and the 8th one is a repetition of the first one. Musical note sa, re, ga, ma, pa, dha, ni. Next comes the same sa. So the 8th note is the first note. Both are having same. With respect to musical notes, here he compared the elements also are having the same type. It is also exhibiting the same type. After 7 elements, the 8th element was showing the properties as that of the first. 8th element is the repetition of the first element property. He gave hence the name as the Newland's law of octaves. Octaves means 8. Here, lithium is the first element. After 7 elements, the 8th element is sodium. Sodium as well as lithium both are showing the same physical and chemical properties. The 8th element property is the repetition of the first element. If you start from beryllium also, 1, 2, 3, 4, 5, 6, 7, 8 is magnesium. Beryllium and magnesium both are having the same physical and chemical properties. Every 8th element property is a repetition of the first element. This was given by Newland. He compared this law with that of the musical note. In musical note, every 8th is the same repetition of the first one. But here this was applicable only up to calcium with atomic weight 40. After calcium, the higher elements, heavier elements, they did not show the similarities as that of these elements. Every 8th element was not the repetition of the first element's property. Only it is applicable up to the calcium with atomic weight 40. Hence, this law is applicable only for the lighter elements, but for the heavier elements it is not applicable. This was given by the scientist name is Newland. Hence the law is known as Newland's law of octaves. But here Newland also grouped the elements, and he said that these elements in the same group, they show the same physical and chemical properties. After this Newland, next scientist is Lothar Meyer-Kerr. Lothar Meyer-Kerr. According to Lothar Meyer-Kerr, here the elements are arranged in increasing order of their atomic weight. The elements occupy the same position, have same physical properties. He plotted a graph of atomic volume versus atomic weight. He got the curves in the form of a peak. He observed that the position occupied by the elements, same position occupied elements, they are having same properties. For example, here sodium, potassium, rubidium, cesium. Sodium, potassium, rubidium, cesium. They occupy the peak positions. Their positions are same. The elements occupying the same positions are having the same physical properties. These elements also exhibit the same physical properties. Hence, he gave that the elements with the same physical properties, they occupy the same position when the elements are arranged in increasing order of their atomic weight. This than the Lothar-Meyer because it was in the form of a curve. It was very difficult to remember the position of the elements in the curve. Hence, Mendeleev got more importance than the Lothar-Meyer. Next comes here the Mendeleev. Mendeleev, his full name was Dmitri Mendeleev. His name was Dmitri Mendeleev and he was also known as Dmitri Ivanovich Mendeleev. He gave this law, Mendeleev's law. According to Mendeleev's law, the physical and chemical properties of elements are the periodic functions of their atomic weight. According to Mendeleev's law, the physical and chemical properties of elements, the physical and chemical properties, of elements are periodic functions of their atomic weight. This was the law given by Mendeleev, hence it is known as Mendeleev's law. The physical and chemical properties of elements are periodic functions of their atomic weights. So Mendeleev related that the atomic weights, as after several intervals of period or gaps, they are having the same elements are having the same physical and chemical properties. Similar to that of the octaves, we told that after every 7th, the 8th element was having the same. But here Mendeleev did not mention specifically, he told just that after certain period of time, the elements are having the same physical and chemical properties when they are arranged in increasing order of their atomic weight. In Mendeleev's periodic table, the elements are arranged in increasing order of their atomic weight. Here, the elements are arranged in increasing order of their atomic weight. The elements having the same properties, they are made in terms of a group. The elements having same properties are grouped together. In group, there is two subgroups are there. The elements on the left of the table is subgroup A and the element on the right of the table is subgroup B. Group 1 elements, in group elements 1 there is a subgroup A and subgroup B. All the elements are arranged in increasing order of their atomic weight and the elements are grouped based upon their properties, similarity in properties. Each group is having two subgroups A and B. The elements on the left side of the table is subgroup A and the elements on the right side of the table is subgroup B. In Mendeleev's law, here in Mendeleev's periodic table, Mendeleev arranged grouped the elements into subgroup A and B. Only from group 1 to group 7 they were having subgroup A and B. But group 8 it was not having the subgroups. He divided the group 8 into triads. I have said just now that I told regarding the triads given by Doberaner. Similarly here the group 8 was having the 3 triads, whereas the group 1 to group 7 he 1 to 7 into subgroup. Each group is divided into two subgroups, subgroup A and subgroup B. Here the Mendeleev's main characteristics are, or main features of Mendeleev's are: Mendeleev's arranged the elements in increasing order of their atomic weights, and he arranged the elements having the same chemical properties in the form of a group. Here you should know what is a group and what is a period. The elements arranged in the horizontal rows are known as periods. The elements arranged in the horizontal rows are known as periods. The elements arranged in horizontal rows are known as periods. The elements arranged in vertical column is known as groups. Elements arranged in vertical columns is known as groups. Mendeleev is having the 7 periods and he is having the 8 groups. The group 1 from 1 to group 8. Mendeleev is having 7 periods and he is having 8 groups. The periods is having 7, and if you see the groups, they are from 1 to 8. Each group is divided into subgroups A and B. Group 1 is having subgroup A and subgroup B. Each group is divided into subgroups A as well as subgroup B. Here you can see the subgroups from group 1 to group 7. You can see the subgroups, but 8 is not having any subgroups. It is divided in terms of triads. 8 is having the 3 triads: iron, cobalt, nickel, ruthenium, rhodium, palladium, silver, osmium, iridium and platinum. These are the 3 triads present in the group 8. But from group 1 to group 7, he divided the subgroups as subgroup A and subgroup B. Elements in the left side represent subgroup A, and elements on the right side of the table represents the subgroup B. If you see this one, lithium, sodium, rubidium, cesium, this is group 1 and its subgroup is A. And group 1 subgroup B is hydrogen, sodium, copper, silver and gold. In this way he made the groups and the subgroups. Only the 7 subgroups, 7 groups are having the subgroups A and B. 8th one is not having the subgroup. It is divided into the triads. The elements, if you observe here, lithium, potassium, rubidium, cesium, the elements present in the subgroup A of group 1 are having same properties. The elements having the similar properties are present in the each group. Elements are having the same properties. Elements in subgroup are having same properties. Elements in subgroup, they are having the same properties. He grouped the elements having similar properties in the form of subgroups, and these subgroups are present in the groups. Here Mendeleev made this arrangement of increasing order of their atomic weight. He even taken into consideration regarding the similarities of the properties of element. Not only he gave importance for the atomic weight, in some places instead of atomic weight he gave more importance for the similarity in the properties. Some of the elements here, if you observe, sodium, copper, silver, gold, these are having the same properties 7 indicates the group number, and the elements present in the group 7 is having valency is +7. Not about the group 8. Only up to 7 he gave the group number itself is a valency of the elements present in that group. It will be very easy if I say group 1. The element belongs to group 1 means it is understood that its valency is +1. The elements are having the valency as well as the group number same. So he classified, he gave the numbers for group based upon the valency of the elements. He taken into consideration the atomic weight. He considered the similarity of physical and chemical properties, as well as he taken the consideration of the valency of the elements. Some of the places here, if you see, they have left blank here. Why these are blank? Because at the time of Mendeleev, only 65 elements he discovered. They were discovered. Hence, he placed in this Mendeleev periodic table only 65 elements. He was having an idea that the new elements will be discovered, and the elements, positions of the elements where they has to be placed. It is he gave the blank spaces for the new undiscovered elements, and even he was having the prediction that the new elements, what will be its atomic weight, what is the density, what will be its melting point. Even he predicted the new unknown elements which will be discovered in the future. And the elements he gave, for example, he gave the 3 elements. The elements after the aluminium, it was a gallium. Just we know that, now we know that it is a gallium, but earlier it was not discovered. Gallium, scandium and germanium, these were not discovered at the time of the Mendeleev. Later the other scientists discovered. He told that after the boron, the element is present. Here he called the element after the boron as Ika-boron. He named that as Ika-boron. Ika means one more. The element after boron, he predicted its melting point, physical properties, and later on the scientists found that scandium as a new element. The scandium, earlier it was named the scandium as Ika-boron. Now we call that Ika-boron. Boron itself is a scandium. After aluminium, he told that another element which was having similar properties of that of the aluminium, he named that one as Ika-aluminium. Ika-aluminium. Now presently we call this Ika-aluminium is nothing but the gallium, which were discovered later. And he gave another that Ika-silicon. After the silicon, he left the gap. He told that the element Ika-silicon is having the same property as that of the silicon. Ika-silicon we call presently, now the Ika-silicon is the germanium. You should know this. Ika-boron is scandium, Ika-aluminium was gallium, Ika-silicon he gave. Now presently we call it as a germanium. They are having the same properties as that of the elements above them. He was able to predict that the elements present in that group will have the same property of the other elements also. Any element, if it is blank, if it is discovered later, the element, newly found elements, the properties of the element is similar to the properties of the elements present in that group. He gave this idea that the elements, wherever it is new elements discovered, he predicted the property of that elements, and his prediction was later came to be, it was a true prediction. Here he told that there are 7 periods. The elements arranged in the horizontal rows known as the periods. Element arranged in the vertical column is known as the groups. According to him, when he discovered, there was 7 periods and there was 8 groups. of this Mendeleev periodic table or achievements or uses of Mendeleev's periodic table. First achievement. Here, since he made the elements in terms of groups as group 1, group 2, group 3, group 4 up to group 8. If I want to study the element cesium, the properties of cesium, rubidium, potassium, lithium, all they are having same physical and chemical properties. So if I study the properties of 8 groups property if I study, that is nothing but the study of all the elements of all the 65 elements property I will come to know. The study of elements, by grouping the elements, the study of elements and its compound made it as easier. This was the first use that studying of elements and compounds made it easier. Studying of elements and compounds was made easier by grouping the elements. By classification of these elements in terms of groups, it was easier. One element, if I know the property, the element's property, other elements will be also having the same property. This was the first. It was easy for the study purpose of the elements. Second one, he left the blank places wherever there was unknown element. Here he left the blank places. He knows that the new element which will be discovered, he predicted the nature of the element, what will be. For example, I told that boron, next element he predicted it is Eka-boron, having same properties as that of boron. Now we call it as scandium. Aluminium, next element was having the same property as that of aluminium. He called it as Eka-aluminium. Now we call gallium. He gave the blank spaces for the undiscovered elements to be filled, and he predicted the nature of the elements also. This was the second is a discovery. Third one, he corrected some of the mistakes made here. He corrected some of the mistakes. Here you know that lithium, beryllium and boron. Initially they thought that beryllium its atomic equivalent weight was 4.5 and it was beryllium was placed in the third group and they considered it as a trivalent. I told you the element in which group means its valence is lithium, its valence is 1, hence it is in first group. Beryllium was first placed in the third group. When it is third group, its valence was considered as a 3. Its equivalent weight was 4.5. When we multiply, it is 13.5. They thought that beryllium should be placed between the carbon and nitrogen, because carbon was atomic weight 2 and nitrogen was 14. Beryllium was 13.5. Where it should be placed? It should be placed between carbon and nitrogen. If we place between carbon and nitrogen the beryllium, what happens here? The beryllium as well as the elements below it, there was no any similarity in properties. Beryllium was having totally different properties, because there was a wrong assumption that beryllium's valency was 3. Beryllium valency was not 3, its valency was 2. 2 into 4.5, it is 9. Beryllium should not be placed between carbon and nitrogen. Its valency is 2, its atomic weight is 9. Hence beryllium should be placed between lithium as well as the boron. Later on he corrected that the position of beryllium is in between the lithium and boron, not between the carbon and nitrogen. When he placed beryllium between lithium and boron, he saw beryllium, calcium, strontium, barium. These elements are having the same physical and chemical property. Hence he placed beryllium in between the lithium and boron. hydrogen. First drawback is position of hydrogen. Where the hydrogen should be placed? The hydrogen is placed in first group. But that hydrogen is showing the properties of that of the 7th halogen groups also, because hydrogen is a non-metal. It is showing the properties of the first group as well as it is showing the properties of the 7th group. When an element shows the properties of both the groups, first and 7, they should be placed here. There was a confusion for the placement of hydrogen, whether it should be placed in first group or it should be placed in 7th group. Here there was no any clear prediction. This was a dilemma. This is the position of hydrogen was dilemma, where should be placed in first or the 7th group. Next, here the positions of isotopes. Position of isotopes. You know that hydrogen is having 3 isotopes. Hydrogen exists as 3 isotopes. If it's all are having same atomic number, what is an isotope? Here the elements with the same atomic number but differ in the mass number is known as the isotopes. They are having 3 isotopes. This is protium with the atomic mass and atomic number is 1. Atomic number is 1. Atomic mass is 2 is deuterium. If atomic mass is 3, it is tritium. Hydrogen exhibits in 3 isotopes. Similarly, carbon and oxygen also exhibit isotopic form. You know that these elements are arranged in increasing order of their atomic weight. Then, where we have to place this protium, deuterium and tritium in the periodic table? We have just to place the hydrogen. Where we have to place the protium, deuterium as well as tritium. There was no position given in the periodic table for the isotopes. This was another drawback. Third one. Here, there are some of the anomalous pairs. Anomalous pairs. Anomalous pairs present here. Some of the elements, you know that they are arranged in increasing order of their atomic masses, means first should be lower, then next should be the higher. If you see here, tellurium, it is 127 is its atomic weight. Iodine is 126, which should come first, iodine next tellurium, but he has placed tellurium first, then the iodine, because fluorine, chlorine, bromine, iodine, they are having same property. Hence, he placed iodine here and tellurium before. Higher atomic number he placed first, then he placed the lower atomic weight. these two dissimilar elements, they are placed in which? They are placed in group 1. Two different elements and two different types of properties are placed in the same group. Dissimilar elements are placed in the same group. This is another drawback of the Mendeleev's periodic table. And here next comes here the lanthanides and actinides. Lanthanides and actinides. In the periodic table, there was no any perfect position given for the lanthanide as well as the actinide elements in the Mendeleev's periodic table. And next comes here the periodicity. What is the word periodicity? Periodicity refers to the repetition of the characteristics of the elements after certain period or gap. If I take this lithium, okay, after lithium next element was potassium. There was a certain gap between the lithium and potassium, but the lithium, potassium, they are having the same property. Why these elements are having same property? The property, these elements exhibit the same property after a certain interval or period or gap. Why these elements are having the same property? This was unable to explain by the Mendeleev. The elements after certain interval or period or gap having the same properties is known as the periodicity. The elements in this group, why they are having the same properties, same physical and chemical properties, it was unable to explain the cause for the periodicity by the Mendeleevs. These were some of the drawbacks of the Mendeleevs.